Well, hello. As she just said, my name is Kayla. And so I didn't spend the summer in Colorado. I spent the summer in Syracuse getting started on my master's research. And so primarily what I'm doing is I'm collecting well water samples, and I'm examining the chemistry data that we get from that. And so what I did for this particular summer, I'm looking at whether or not formation water is present in New York state wells in the southern part of New York. Okay, so is formation water mixing in shallow drinking water in New York? So your first question is probably like, what the heck is formation water? So formation water is going to be like a layer of water that underlies the oil and gas layer inside of a formation. So like, for example, the Marcellus Shale, where they're thinking about extracting gas from. So underneath, like within that layer, there would be formation water underneath that. So formation water typically has really high chloride concentrations, very highly saline, and so the waters that we looked at was about 60,000 to 130,000 parts per million of chloride, and seawater is typically around 19,000. So you can see that like there is really high salinity, like greater than seawater. And the reason that we care about this is because there's potential for hydraulic fracturing to take place in New York. And so we have, so the concern is that fracturing can create pathways for shallow groundwater to be contaminated. And so if you look at this, you can see that there's the groundwater layer. So that's typically where your shallow drinking water wells are going to be. And if you look all the way down where like the gas shale is going to be, your formation water is going to be underneath that. And so one of the arguments that are present when you talk about contamination in terms of hydraulic fracturing is that there's too large of a vertical separation present for there to be any contamination to take place. And you can see that like groundwater is going to be like maybe around 50 or 100 meters, and then the formation water is like below like 4,000 meters. So it's a huge separation. So the reason why we're really interested in this is because this study could show that natural pathways for formation water to contaminate groundwater wells already exist. So if hydraulic fracturing were to occur, it could be an indication that it might make even more pathways. So, so this is the Marcellus Shale. The colors represent thickness. And so we're focusing primarily in the southern tier of New York, so like 6 counties in New York. And so what we're doing is, so we just started our sampling season for this year. And last year we took 60 well water samples. This year we're aiming for 120, so we're growing. And so what we're going to do is we want to basically compare the groundwater chemistry that we collect and compare that with the formation water chemistry to see like if they correlate. So for this study, what I did was I looked at a paper that came out of Warner et al. 2012. And so he looked at Pennsylvania, where hydraulic fracturing is already occurring. And he looked at the bromide concentrations versus the chloride concentrations. So you have bromide on the y-axis and chloride on the x-axis. And what he did is he calculated a mixing line. So if you take your shallow groundwater samples, and then you have that are like have very low salinity, and then you take your formation waters, which have very high salinity, and then you say, well, if I mix this amount of formation water with this amount of groundwater, what percentages would I get? And you create a mixing line. And so then after you do that, so you can plot your data on this plot, and you can see that his high salinity waters, which are his red diamonds, they fall on this mixing line. And if they fall on the mixing line, then you can infer from that formation water is probably mixing in these wells. Like the reason that there's this high salinity is because there's mixing with formation water that's occurring. So this is what we did with the samples that we got for New York. We did a similar thing. So we took the 60 samples that we had from last year and we combined them with data from the USGS and from NURI, which was also hosted by the USGS. And we took all of this groundwater chemistry data And basically, we characterize the groundwater the same way that Warner did. So we have our type A waters and our type B waters, which are low salinity, less than 20 milligrams per liter of chloride, and then our type C and D waters, which are high salinity, greater than 20 milligrams per liter of chloride. And then we also, so I created a map just to see like what the geospatial distribution of this, and you can see that clearly like there's really no pattern. So you have like your type A, which are the green boxes, right next to like your type B, which are your red circles, and like they're right next to each other. So really there's no correlation between like where you find the high salinity samples and where you find the low salinity samples. So after we categorized this data, we made our lovely plots. And so you can see on this graph, so this first graph on your left, you can see that, so you have your bromide concentrations on your y-axis and your chloride concentrations on your x-axis. And similar to the Warner study, we get our type D waters, which are our high salinity waters, falling on this mixing line that we calculated. So this could be evidence that in New York, where currently there's a moratorium on hydraulic fracturing, that formation water is mixing with the groundwater in this area already. And so also, if you look at the sodium concentrations versus the chloride concentrations, you can see again that these type D waters are falling on this mixing line, so that could also be evidence. So for this study, when we did our mixing line, we can see that it would probably be about a little less than 1% of mixing with formation water, which is really not a lot at all. Which actually was probably why we got such different graphs when we looked at other ions. So as you can see for these graphs, that really there is no linear trend between any of the groundwater data and the formation water, like at all. And so we were curious as to why this could be, and it's probably, so if you're assuming that, yes, this formation water is mixing with the shallow groundwater, then, and you look, and it's less than 1%, then it could just be that because it's like such little mixing, that it's just not affecting the relationship between these other ions. However, there's also the possibility that the absence of these relationships could suggest that this salinity that we're seeing, or the relationships that we're seeing, could be associated with other sources that aren't formation water at all. And so that would be like future work, because I don't have that information yet. Okay, so what conclusions can we draw? So if we just look at the bromide to chloride concentrations, or like the sodium to chloride concentrations, then you would be able to say that perhaps there's presence of formation water in these New York groundwater wells without the presence of hydraulic fracturing. However, if you look at the other graphs and you see that there's this absence of data, this absence of this linear relationship, this could also suggest that it's contradictory. So this high salinity could be associated with contamination from another source, such as like landfills or septic effluent or road salt. So for our future work, we would like to get ground chemistry data for these other sources and like plot them on this graph and see, well, do we have a better relationship with these other sources? Like, can this be explained in a different way? Another thing that we're hoping to get are strontium isotopes for the groundwater samples, because it would like make life so much easier. And if you look at the strontium isotopes for the groundwater and the strontium isotopes for the New York formation water, it should be similar. And specifically, the strontium isotopes for the Marcellus Shale typically are pretty low. So once we get those strontium isotopes, hopefully we'll be able to say more about this. Okay, so I'd like to thank my professor back in Syracuse, Jenny, who like helped me a lot with this presentation. My grad students, Aisha, Melissa, because you're fantastic, RESESS, and UNESCO. Oh, and Syracuse, because, you know, they accepted me. Yeah. I wouldn't be doing this project if I hadn't gotten in. So, questions?
So fabulous presentation and really interesting work. You mentioned that you're looking at, you collected, there was recent data collected that you're looking at, but that there's some historical data. Could you talk a little bit about the extent of that kind of data that's already been collected? Because I'm sure that it's going to be really critical as more and more areas in New York and across the country look at hydraulic fracturing.
Yes. So specifically for the project that we're doing at Syracuse, last year we went out and we started our sampling and we took 60 groundwater samples. There was a USGS study done that I think had about like 600 groundwater samples, and a NURI study done that had about like 89 samples. Or that might be reversed actually. And they all have like this groundwater chemistry like in the same area. And so just like like comparing that, like it's actually really helpful, and it'll be really interesting because I think the NURI data and the USGS data isn't as recent as ours because we just took our samples last year. So it'll be really interesting to see if there's like a change. So I'm really excited to get these to get these samples from this year because we'll have more, and we'll be like, well, you know, has the groundwater chemistry changed since these older samples were taken? But also, it'll be nice to get more samples from our study because everything will be consistent. And like one of the things that I really was interested in doing is just seeing how depth, like the depth of the well, like if that had any effect on like whether like the salinity, you know, like if the higher salinity samples were due to the depth of the well or something like that. And it's just that like you have absence of data, like well depth data. So it'll be really interesting once we get off of our data and it's consistent.
I was really curious about whether or not you thought that the 1% mixing that you saw was a result of formation water, or as a result of the other things you named at the end of your study in terms of road salts. And if it is formation water, how did it get like 3.5 kilometers up?
I will be completely honest. I have no idea. Personally, I'm not entirely convinced that formation water is mixing. I don't think you can really draw that conclusion from the results that I have. I definitely would be hesitant to say that we definitely need more data on that. And so I wouldn't necessarily say yes, absolutely formation water is mixing. And if it is, I'm not really sure how. Yeah. So I'll let you know in 2 years when I'm done with my master's. Any other questions? I actually had a question. Okay.
So you talked about this previous study that was done in Pennsylvania,
yeah. And
he sees this mixing line. Does he talk at all about how that relates to what's already happening in Pennsylvania with hydraulic fracturing?
He does talk. So he has like some other information. Like he looks at the water isotopes. He actually has strontium isotopes for his data, which is so nice. And so he does talk about that. And what he basically concluded was that I think for his data, like the locations of his wells compared to where the gas flows are, like it was far enough away that he didn't think that it was due to like the fracturing. And then like I'm pretty sure I would have to look at the study again, but I'm also pretty sure that just looking at the strontium isotopes, there was a correlation there. Yeah.
Thanks. All right. Let's thank Kayla again.